Okay, welcome back to my YouTube channel. You're going to join my class today and you are concluding the topic called the bonding. Previously, we did what is called ionic bonding. We said there are three types of bonding. We have ionic bonding, we have covalent bonding, and metallic bonding. Right? Then we did the first part, which is the ionic bonding. Today I have to do the covalent and the metallic at the end. We'll also be solving some questions along. So we need to know what is covalent bonding. So what is covalent bonding? What is covalent bonding? So covalent bonding is a type of bonding which involves the sharing of outermost electrons, the electrons which are found in the outermost shell. So electrovalent bonding is a type of bonding which involves the sharing of electrons. Unlike the ionic bonding, which we said that there is the losing and gaining of electrons. In the covalent bonding, there is no losing and gaining. Here they share electrons. So covalent bonding is a type of bonding which involves the sharing of electrons which are found in the outermost shell. So covalent bonding is the sharing of electrons. Is the sharing of electrons found in the outermost shell. That is what is called the covalent bonding. So it involves the sharing of electrons. Now the other name for covalent bonding is called the ionic, molecular bonding. So it is also called the molecular bonding. It is also called molecular bonding. So covalent bonding is also called molecular. So when you hear the word molecular bonding, it's not different from covalent bonding. They're just one and the same thing. So covalent bonding is also called the molecular bonding. So this type of bonding occurs in non-metallic elements, between nonmetals. You get that, right? So a covalent bonding takes place between nonmetals. So it occurs among nonmetals or between nonmetals. So it occurs between non-metallic elements, nonmetals. So covalent bonding occurs between nonmetals. Compared to ionic bonding, we say that it is between a metal and a non-metal, but this occurs between nonmetals. You get that, right? So that is what is called the covalent bonding. So it's a type of bonding which involves the sharing of electrons, and those electrons are talking about the electrons which are found in the outermost shell. All type of bonding occurs in the outermost shell. You get that, right? Yeah, so that's what is called the covalent bonding. Now you need to demonstrate how this covalent bonding takes place. How do they share electrons? So let's start with the hydrogen gas. Let's show how electrons are shared in the hydrogen gas. So just like I said earlier, you cannot draw the structure for these compounds without knowing their valence numbers, without knowing the formula of which you did earlier. So hydrogen gas. What's the formula for hydrogen gas? It's what? H2. Hydrogen gas. Hydrogen atom is just H. The symbol for hydrogen is H, but gas it is H2. You get that, right? Which simply means that two hydrogen atoms have shared electrons to form the hydrogen molecule. So the hydrogen gas has a formula, the H2. So now, how did these two hydrogen atoms share electrons? So we're going to separate them. We have this hydrogen here. We also have the other hydrogen there. We need to know the number of protons, electrons, like that. So we have the atomic number 1, the mass number 1. Same applies to that. The same thing like that. So you need to know how many electrons are there. This is the proton number. The number of protons is equal to the number of electrons, which means the hydrogen has 1 electron, isn't it? So if you are to write the configuration, we have 1 there. We also have 1 there. Now, the first shell, when you had used the formula, we were told that we must have 2 electrons in the first shell. Hydrogen has only 1 shell, is it? Now we have 1 electron, which simply means that it needs 1 more electron for it to attain this stability. You get that, eh? Yeah, so now the number of electrons it needs to be stable are the same number of electrons which it has to share. So if it needs 1, it has to share 1 electron. You get that, eh? Yes. Okay, so what will happen here? We're going to draw the hydrogen, the shell, the outermost shell. We all have 1 anyway. So just draw the shell for hydrogen. Now to show that they are sharing electrons, these shells must interlink with each other. So you can either draw it like this, or they can just touch like that. You just touch like that, you don't form a second between. This and this is okay. It's the same thing. So this part is showing that they are sharing electrons. The electrons which are being shared will have to be placed in here. Okay, so this hydrogen atom which is here needs 1 electron to be stable. And I said that because it needs 1 electron, it has to share the same electron. You get that, right? So the hydrogen, this one needs 1 electron, so it will share 1. Now this hydrogen also, it has been given 1. It can't give 2. It also has to share 1. You get that, right? They always share equally. So this hydrogen will also share 1 electron. I'm using the same symbol because this is the same element, hydrogen, hydrogen. You get that, right? Okay. Now, if you count here, we had 1 electron here. So there is nothing remain to put outside here because the same 1 electron has been shared. Same applies with that. So this is the structure for the hydrogen gas. Is there a problem here? No. No problem. Okay. Pause it. So apart from the hydrogen, let's demonstrate the formula, the structure formula for water. The structure formula for water. Water has a formula, the H2O. So when they ask you a question, they'll ask you to say, draw the electronic structure for water molecule. So that's a molecule, water molecule, which is the H2O. You get that, don't you? Now, when asking question here, sometimes they can specify, they would say, showing all the shells, all the electrons. You get that, right? Sometimes they'll just say, showing the outer electrons. When demonstrating bonding actually under covalent bonding, we only show the outer shells. But when they say showing all the electrons, it means we have to show all the shells present. You get that, right? Okay, so here we have 2 elements. We have hydrogen and the oxygen. So we have the hydrogen here. We also have the oxygen there. We have 1, 1 as usual. What's the atomic number for oxygen? 8. Then we have 16 there. Okay, so the configuration for this one, we have 1. Then the configuration for this one, we have 2, 6. Which means that if you consider those rules, you say that those with this, it needs more electrons for it to become stable, is it? It needs 2 electrons for it to become 8. This one needs 1 for it to become 2 because the first shell must have 2 electrons. Okay. So now how are we going to demonstrate the bonding here? Here we have different atoms. We have 3 atoms, 2 atoms of hydrogen and 1 atom of oxygen. So now when drawing here, we have to balance. We cannot draw oxygen here, then the 2 hydrogen, like that. No, we have to balance. Oxygen this time will be in between. You get that, right? Oxygen will be in between so that we can easily balance the electrons. So we'll have oxygen at the middle. We have hydrogen this side and the hydrogen the other side. Even the structure will look exactly that way. So we draw the outer shell for hydrogen like that. We draw the outer shell for oxygen. Remember, they have to interlink like that. We draw the outer shell for hydrogen, another hydrogen atom there. So that is hydrogen, that is oxygen, and that is hydrogen as well. So if they say show all the electrons, it means we have also to draw this shell which has 2 electrons, which will be inside here. You get that, right? Demonstrate it like that. But if they didn't say show all the electrons, we don't want that. We just want the outer shell to demonstrate the bonding among these atoms. You get that, right? Okay, so this hydrogen atom, this oxygen atom has 6 electrons in the outer shell. This one has 1, that one has also 1. Now, these hydrogen atoms need 1 electron for it to be stable. So the same number of electrons it needs to be stable is the same number of electrons it has to share. So this hydrogen needs 1, so it will share with oxygen 1. So the hydrogen will share 1 electron there. Now, this oxygen has been given 1 electron. It means the oxygen also will contribute 1 to this hydrogen. So we have to use a different symbol because these are two different atoms together, right? It's oxygen and the hydrogen. Okay, the same thing will happen here. This hydrogen needs 1 to be stable, so it has to share this one. So once it shares this one gone, we no longer have that, right? It has shared it here. Then this also do the same thing. It will share 1 electron. Then the oxygen will also contribute 1 electron there. You see that, right? So for this again, we don't have any. Now here we are D6 and it has shared 2. How many are remaining? It means we have remained with 4 electrons here. You see that, right? So now this 4 has to be written in this shell. So 2 will be here, 2 will be there. So this is the structure for the water molecule. So when you count these, for oxygen we must have 8. 1, 2, 3, 4, 5, 6, 7, 8. For hydrogen we must have 2. Remember that's just the first shell, is it? 1, 2, this one, 1, 2. They are sharing these electrons together, right? So that is the structure for water molecule. Pause it. Okay, so just one more last example. We'll look at one organic compound, at least because they also ask a question on organic compounds under body, and because they also covalent compound because they're made up of non-metals. They can ask about methane, they can ask about ethane and the like. So we'll draw the structure of ethane. Draw the structure of the ethane. Later on, you'll discover what ethane is when you reach there. So ethane is one of the organic compounds which has the formula, or maybe we have any person with an idea what the formula for ethane? No idea.
Yes.
No. Okay, so we have the C2H6. C2H6. That is the formula for ethane. C2H6. So when they say draw the structure formula, okay, not really the structure formula in the organic compound. When they say draw the molecular formula for ethane, we want to show the electrons, the bonding. You get that, eh? Because since this is an organic compound, when they say draw the structure formula, they would probably mean you drawing those things we know under organic, right? This is also the structure formula. Now we want to show the electrons, the electronic structure for ethane. You get that, right? So to show the electronic structure, we have to draw these kind of structures. It's not so much different from these as well. It's very similar. You get that, right? It's very similar because these are representing the bonding. Here will be hydrogen, here there will be hydrogen, here there will be hydrogen, there hydrogen, here hydrogen, here hydrogen. But when we want to show the electrons, the way they are sharing electrons, we have to draw it this way. You get that, right? Which simply means that we have to draw first 2 carbon atoms. So we have this carbon atom here, and if you see they are bonding carbon to carbon, there's a bond. You see that, right? So carbon to carbon, they have to share electrons. So this is carbon and this is carbon. So this carbon here has 3 hydrogen. You get that, right? Hydrogen in its nature, it has a valence number of 4, which simply means that it has the ability to form 4 bonds. The valence number is the number of bonds that atom needs to form. You get that, right? So oxygen, we say that it has a valence number of 2, which means it has to form 2 bonds. These are the bonds which are here. 1, 2. You see that, right? Now carbon has a valence number of 4. It has to form 4 bonds. So already there is this bond here. You see that, right? Between this carbon to carbon. And let me use the X to represent that. So this carbon will share 1 electron to this carbon. This carbon also give 1. You get that, right? You have to use the same symbol because they are the same atoms. Now this carbon atom here has 3 hydrogen. You see that, right? there are 6 hydrogen, which means they are sharing 3 each. This one is getting 3, this one is also getting 3. So we have one hydrogen here, we have one hydrogen there, we also have another hydrogen there. The same thing is happening there. We have one hydrogen there, another hydrogen there, another hydrogen there. So these are hydrogen atoms, like that. There's nothing strange, that's the same thing, is it? Okay, now this hydrogen, the same ability, it has a valence number of 1, and it needs just 1, just to form one bond, right? So this hydrogen, it needs 1 electron to be stable, which means it will share that 1 electron here. So I'm going to use the dot for hydrogen now, since I've used the X for carbon, right? So because it has shared 1 electron, the carbon also donate 1, so that they can share, equally. Again, this one, the same thing is going to happen. So the hydrogen will donate 1, then the carbon also donate 1. Hydrogen will donate 1, carbon will also donate 1. You see that, eh? You go to the other side, hydrogen will donate 1 here, carbon will donate 1. Hydrogen will donate 1, carbon donate 1 there. Again, hydrogen will donate 1, carbon will donate 1. If you are to count there, you discover that this is stable. Carbon must have 8, hydrogen must have 2. You see that, eh? So this is the structure for ethane. That is the structure for ethane. So when they ask a question like that in an exam, you should be able to count how many atoms. We did how to count atoms, elements, and the like. How many atoms are there? There are 8 atoms, right? Good. Yes, we have 6 hydrogen, 2 carbon, 8. Okay. We now look at the physical properties of covalent compound. The physical properties of covalent compound. What are some of the physical properties of covalent compound? What are some of the physical properties of covalent compound? Yes. It occurs between nonmetals, eh? It occurs between nonmetals, okay? So it is between nonmetals. So covalent compound is a compound which is formed between nonmetals. Apart from that, covalent compound, they have low melting and boiling point. They have low melting and boiling point. Low melting and boiling points. So covalent compound, they have low melting and boiling points. Covalent compound, they are soluble in organic solvent but insoluble in water. So they are insoluble in water. It can't dissolve in water, but it can easily dissolve in organic solvent. So they are soluble in organic solvent. What does the word soluble mean? It can dissolve, right? So in organic solvents, but insoluble in water. You give an example of candle wax, right? Wax, if you put wax in water, can it dissolve? But have you tried to put wax in kerosene? Paraffin, kerosene. Rather, you should try. Yeah, you should try. It does. So it can dissolve in organic solvent, but it can't dissolve in water. You get that, right? Okay. Then these are volatile. Generally, they are volatile. They change states. You get that, right? so they are volatile. Let's say generally, when I say generally, it means there's some exception, eh? So generally, they are volatile. You know what generally means? So generally, they are volatile. They change states. You can give an example of water. Water can be liquid. We have solid. We also have, vapor, is it? So they change states. Okay. Then, apart from that, they do not conduct electricity, whether in fused states, molten state, except graphite. So covalent compound cannot conduct electricity. You get that, eh? Except graphite. There is an exception. Graphite is an exception there. So they do not conduct electricity. They do not conduct electricity except graphite. Graphite doesn't, it does conduct electricity. Eh? That one has the ability to conduct electricity, but it's also a covalent compound. So we have some exception there. So also they have relatively low density and many more. So these are some of the physical properties of a covalent compound. So when they say give any example of a covalent compound, you must think of a compound which made up of nonmetals, which includes acids. Acid, for example, hydrochloric acid, it is also a covalent compound. There is no metal. Talk about sulfuric acid. As long as that compound doesn't have any metal in it, it means it is what? It is a covalent compound. You get that, eh? Is there any question there? Is there any questions there? No questions. Okay, so we look at now metallic bonding, which is the last part of this topic. You look at metallic bonding. Metallic bonding. What do you think is metallic bonding? What do you think is metallic bonding? Metallic bonding is the type of bonding which is found or which exists within a metal. A lot of people make mistake there. They will say between metals. It's not between metals. It is within a metal. It occurs between the positive charged, cation and the negative charged electrons. The bond between the ions and electrons. That is what is called metallic bonding. So metallic bonding is the bonding which exists within a metal and occurs between. So metallic bonding is the bonding which exists within a metal and it occurs between the positive charged cation so the positive charged ions, which are called cation, is it? And the negative charged electrons. So negative charged electrons. Electrons are negatively charged. We looked at the properties of these subatomic particles. Electrons are negative charged. So metallic bonding occurs between the ions and electrons. Ions are positively charged. So these ions they have the ability to repel. They can repel from each other because they are positive. Positive repels. Now, because of the existence of these negative charged electrons, there is that strong attraction between the negative and the positive, which which imbides these ions together. So the force of attraction between the negative charged electrons and the positive charged ions is stronger than the repulsive forces between the positive charged ions. You get that, eh? So it is stronger. That is why these ions are held together. You get that, eh? So these electrons we're talking about are mobile. They are what are called they can move from one place to another. They are mobile electrons. You get that, eh? Yeah, so these electrons are mobile. That's why they're called free electrons, eh? The electrons are free to move from one place to another. Hence, this makes this makes metals to become or to be good conductors of electricity. So hence, this makes metals to be good conductors of electricity. What is electricity? Have you ever asked yourself that thing? What is electricity? Electricity in physics is defined as the flow of electrons. So these are the electrons we're saying that they are flowing. They are free. They are what are called delocalized electrons. They are able to move from one place to another. You get that, right? Because they are mobile. So they are called the delocalized electrons. At the end, we're going to say their electrons are called delocalized because they have the ability to move. Local is a place. So delocalized, they're able to move from where they are to the other place. You get that, right? So because of this ability, these electrons moving from one place to another, metals are good conductors of electricity. So when they ask to say, explain why metals are good conductors of electricity, or perhaps they can specify certain metal like a copper, they can say aluminium. Why is aluminium a good conductor of electricity? It is because of the delocalized electrons which have the ability to move from one place to another. You get that, right? This is the property which makes it, metals to be good conductors of electricity. Okay, now if they ask you to say draw the structure to demonstrate the metallic bonding, for example, in copper. So we just draw a certain box representing that this is a copper metal. Now remember, it is the bonding between the positive charge ion and the negative electron. So you draw the copper ion, depend what copper is, could be copper 2, copper 3, the valence number is not fixed for this one. So right, for example, if it's copper 2 plus, then we have the electron which is negative. You see that, right? We have again copper 2 plus, we have the electron which is negative like that. So the bonding is existing between the copper ion and the electrons. You see that there? So we have the electron there, negative charge. We have the copper 2 plus. We have the electron, negative charge. We have the copper 2 plus, like that. Another electron there. We have the copper 2 plus. Cu is the symbol for copper. Okay, copper 2 plus. We have the electron there, negative. We have the copper 2 plus, we have the electron, negative. Okay, I'll cut it here. Like that, we have the copper 2 plus, we have the electron there, and the like. So copper 2 plus. So this is the bonding within a metal. The bonding which exists between the positive charged ion and the negative electrons. You get that? So when they say draw the structure for a certain metal, if it's aluminium, it means where we are writing the Cu2 plus, we'll be writing now the Al3 plus because aluminium has a valence number of 3. So we need to know the valence numbers, right? Okay, so it depends with what metal have been taught to draw the structure. So it's not specified. It depends on which metal have been taught to do together, right? So this is what is called the metallic bonding. You get that, eh? Now, if I were to talk about the physical properties, metallic bonding, they have very, very high melting and boiling point because the force of attraction between the positive and the negative is very strong. So metals have very, very high melting and boiling point compared to even ionic compounds. You get that, eh? So these are very high melting point. They have high density. They are solid at room temperature and pressure, except for which metal is not solid? Which metal is not solid? Mercury. Good, yes. So metals are solid at room temperature and pressure, except for mercury. Mercury is always a liquid. You get that, right? So those are the physical properties of metallic bonding. Okay. Pause that. That's a question. Okay, so let's consider this example regarding bonding. Specifically, this structure is under covalent bonding, as we can see. So, element E, whose proton number is 7, combine with hydrogen to form a gas. And that's the structure being described. This is a gas which has been formed, the hydrogen combined with element E. Then question A, identify element E. Identify element E. Yeah, you may need the periodic table if you don't know that much about it, but obviously the proton number 7, we should know that element. We don't even need the periodic table. What could be this element E? Nitrogen. Good. Yeah, so A is nitrogen. So element E is nitrogen. Element E is nitrogen. Okay. Nitrogen is the element with the proton number 7. B. What is the name of the gas? What name of the gas is formed when nitrogen combined with hydrogen? Ammonia. So we have ammonia. We have ammonia gas. Ammonia is a gas formed when we now go to question C. Write the chemical formula of the gas. So C, what's the chemical formula for ammonia? NH3. Good. So NH3 is the chemical formula for ammonia. D. What type of bonding holds the atoms together in this compound? We have looked about 3 types of bonding: ionic, covalent, and metallic. So what type of bonding is holding these atoms together? Covalent bonding. Okay, cool. So we have covalent bonding. Covalent bonding. Then E. State one physical property of the gas that is due to the type of bonding it has. So the question is very specific. If they just say the physical property of ammonia gas, you can talk about the choking smell. You see that, right? It chokes, but you don't want that because that is not as a result of bonding. So here we want the properties of covalent bonding in this case. So what is a property of covalent bonding? Just one. Low melting and boiling point. It is made up of non-metals. It has low density. It is volatile. What else? Look at. You can add more, right? So low melting and boiling point, eh? Low melting, low boiling, low density, and the like. So you can just choose from those. So I would like low density. F. Name another compound which has the same type of bonding. Name another compound. Ethane. We have water. We have carbon dioxide. Hydrogen gas is not a compound. A compound has 2 different atoms, right? Yeah, so we don't want that now. We want a compound, right? So talk about water. We'll talk about just water to make it easier. Talk about carbon dioxide, talk about hydrochloric acid, sulfuric acid, nitric acid, and the like. You get that, eh? Okay, so that's all for this topic. Can